So as we talked about in the last 2 weeks about exponent rules, or 4 of them, one of them involves basically multiplying the same base over and over and over again. And so if we have this situation, what we do is we add the exponents together to figure out how many of the x's we have. It could be y's, it could be numbers. Power rule. The big difference between power rule and the product rule is the power rule always involves parentheses. The product rule does not. Under the product rule, we multiply the exponents. Quotient rule, unlike the product and power, is always a fraction. And to be able to figure out the answer, we subtract the exponent. So all the problems we talked about look very different. The product rule does not use a fraction, does not use parentheses. Power rule does not use fractions, and the quotient doesn't use parentheses. I mean, they all look very, very different. The zero rule actually comes from the quotient rule. The big difference between the two is that the exponent in both the numerator and denominator are the same exponent. It's the same exponent. So therefore, when you subtract them, you get a zero. Hence why it's called the zero rule. Because the numerator and denominator is the same value, is like 3 squared over 3 squared, or x to the 7th over x to the 7th. Since we're talking about the same number of x's or numbers in both the numerator and denominator, that fraction will always simplify to 1. So anytime you have an answer of something to the 0 power, as long as that variable doesn't have a value of 0, it always equals 1. So we will replace any expression or factor of something to the 0 power with a value of 1. So here are 4 problems. So turn off the video, complete the 4 problems. When you're finished, turn the video back on. So I thought for this week, we'd spend some more time practicing the different rules. Next Monday, Tuesday will be a retake over your assessment from last week. I will be releasing those test results on Thursday, or if your class happens to be on Friday, it'll be Friday. So this is the product rule, so we're going to multiply the exponents. So we're going to have 2 times 2 for the 6, and negative 3 times 2 for the x. So we end up with 6 to the 4th times x to the negative 6. In the directions, it says make sure all of your exponents are positive. So the 6 to the 4th will stay in the numerator because the exponent on the 6 is a positive number. But the x will go to the denominator because the exponent's negative. So therefore it doesn't belong in the numerator. Those x's, because the exponent's negative, actually belong in the denominator. In problem number 2, it's another power rule. So we're multiplying again. So we're going to have 5 times 3 times 0, x times 2 times 0, y times 3 times 0. So we end up with this 5 to the 0, x to the 0, and y to the 0. Because we have something raised to the 0 power, that means all of those become 1. So the final answer to this problem is 1, because basically you're multiplying 1 times 1 times 1. In the third problem, we have a fraction, which means we have the quotient rule. So we're going to subtract the exponents. So it'll be 6 minus 9 on the x. And for the y, because we have an exponent of 1 here, it's implied to be 1 if it's not given. It's 5 minus 1. So 6 minus 9 is negative 3. 5 minus 1 is 4. So in our final answer, the exponent on the y is positive, so it stays in the numerator, but the exponent on the x is negative, so it goes to the denominator. So it's y to the 4th over x to the 3rd. In the last problem, we don't have parentheses, there's no multiplication, we don't have fractions, we're not subtraction. This is just simply multiplying a base to another like base. So when we do that, we just add the exponents. So it'll be 2 plus negative 8 on the x, and 3 plus 5 on the y. So we end up with x to the negative 6 times y to the 8th. And the final answer, the exponent on the y is positive, so it stays in the numerator. The The exponent on the x is negative, so it goes to the denominator. Okay, second set of problems, there's actually two sets. This is the second and final. Please turn the video off and complete the problems. When you're finished, turn the video back on. So in the first problem, we have quotient rule because we have this fraction here. So we're going to take the exponents and subtract them. So -3, take away -5. It's not -3 minus 5. You're taking away a negative number. Y is 6 minus -3. And the z is 2 minus 2. So the x ends up being a positive 2. -3 minus -5 is positive 2. The y, the exponent, is positive 9. And the z, the exponent, is 0. Because we have an exponent of 0, assuming z does not equal 0, we replace that with a 1. So the final answer here is x squared y to the 9th. In problem 6, we don't have parentheses, so we're not multiplying. We don't have fractions, we're not subtracting. What we just have is a string of bases, 3's, x's, and y's. So when we have this, we just add the exponents. So we have an x, a base of 3, a base of x, a base of y. So the 3, we're going to add 2, -5, and 2. For the y, we're going to add, for the x, we're going to add 2 and 5. And for the y, we're going to add 3 and -5. So for the 3, it's a an exponent of -1. The x is 7. And for the y, it's -2. So in the final answer, the x stays in the numerator because the exponent's positive. The 3 and the y will end up in the denominators because the exponents are negative. So it's 3 in the first, you can leave the 1 off, times y squared. In problem 7, we have parentheses, so we're going to be multiplying. So 8 to the 2 times -2, 7 to the, x to the 7 times -2. And y is -2 times -2. So for the 8, the exponent is -4. For the x, the exponent is -14. And for the y, the exponent is positive 4. Since the y has an exponent that's positive, it will stay in the numerator. The 8 and the x will both go to the denominator because the exponents are positive. And again, when I put it in the denominator, the exponents become negative. For the last problem, there is nothing to subtract. There's no c in both the numerator and denominator. There's no d in both numerator and denominator, same with the y. So and we have nothing to combine like in problem 6, and we don't have any parentheses. What we have, though, are negative exponents. This c and this d need to be moved to the numerator to make the exponents positive. So the y stays where it's at because the exponent's positive. The c will move to the numerator, and the d will move to the numerator, and those exponents will become positive there. So the final answer is c cubed times d to the 5th all over y squared.